Hello everyone, welcome back to Statistics.Education. If you are new here, don't forget to hit the subscribe button and ring the bell icon so you never miss our upcoming videos. In today's video, we will learn what is classification of data. So let's get started. Let's take a look at the topics covered in this video. First, we will learn about two types of variable. The first one is discrete variable and the other one is continuous variable. After that, we will take a look at raw or ungrouped data, followed by classified data. And lastly, we will wrap up with a practical aspect, that is discrete frequency distribution. So let's start the video with discrete variable. A discrete variable is a variable that can only take specific separate values. These values do not have any in-between values. For example, a discrete variable might have values like 1, 1.1, 1.2 and up to 5 and nothing in between these values. So, there is no value between 1 and 1.1. There is no value between 1.1 and 1.2. Similarly, the number of books on a bookshelf. There can be 10 books or 11 books, but there cannot be 10.5 books. Okay? In a family, there can be 1, 2, 3 or more children, but there cannot be 1.5 or 2.67 children, right? I hope these examples will help you to understand discrete variable. Now let's understand continuous variable. A continuous variable is a type of variable that can take any value within a range. It can have an infinite number of possible values. For example, height, weight, temperature and time. Here you can see height can be 175.5 centimeters, 175.55 centimeters, 175.555 centimeters. Similarly, the time can be 3.4 seconds, 3.45 seconds, 3.459 seconds. It can go up to infinite, and thus it is known as continuous variable. For example, in Olympics, the height, distance and time are measured and even the minute difference can be decisive. I hope this example will help you understand what is continuous variable and how it is different from discrete variable. Now let's move on to raw or ungrouped data. Data obtained from the inquiry is in unorganized form. Such data is known as raw or ungrouped data. Raw data is just a set of values which needs to be arranged to analyze further and to make interpretation. For example, the following data shows number of children per family of 30 families of an area. But from these observations, it is difficult to identify how many families have 0 kids or how many families have 2 kids. Of course, we can count it, but this is a very small data. What if instead of 30, there are 30,000 observations? Thus, such data is called raw data, which is just set of values. Okay? I hope this example will help you understand raw data. Now let's learn about classified data. A systematic arrangement of raw data is known as classified data. This process of arranging raw data is known as classification of data. Classified data is useful for analysis and interpretation. So this is raw data. It is difficult to analyze and interpret this data. While by grouping this data or classifying this data, we can easily analyze and interpret this data. This will allow us to identify how many families have 0 child, how many families have 1 child and likewise. The total frequency shows the total number of observation. In this case, it was 30 family, so the total is also 30. If any observation is skipped or missed, we can come to know with the help of total frequency. Now let's learn about the types of classification of data. The classification of data can be of two types. One is classification of quantitative data and the other one is classification of qualitative data. The quantitative data classifications are of three types. The first one is discrete frequency distribution, the other one is continuous frequency distribution, and the third one is cumulative frequency distribution. And the qualitative data classifications are of two types. The first one is simple classification and the other one is manifold classification. In this video, we have covered discrete frequency distribution and the remaining classifications are covered in upcoming videos. With this done, let's start the practical aspect of this chapter, where we will learn how to solve the sums. Discrete frequency distribution. Here you can see a question. Let's read and understand it. The following data shows the number of patients admitted to a hospital during June 2024. From this data, prepare a discrete frequency distribution. So from these observations, we are supposed to make a frequency distribution table. Now first let's identify the smallest value and the largest value from these 30 observations. As we can see, the 0 is the smallest value in this data and the largest value is 10. Now with these details, we need to make a table like this, starting from 0 to 10. Along with this table, you are required to prepare two more columns. One is for telemarks and the other one is for frequency. If you have attended any class monitor selection, you might have seen this type of telemarks to be done by the class teacher to count the votes. Each set of telemarks contains 5 lines. This makes it easy to calculate the sum later. If there is a series of lines, it will be little difficult to add up those lines, and there is a possibility that a few lines are omitted in the counting process. So to solve that, the sets are created. Now we need to read the numbers one by one and put a tally mark against them. Easy, right? So let's get started. The first value is 5, so we will put a tally mark against 5. The next value is 7, so we will put a tally mark against 7. The next value is 9, so we will put a tally mark against 9. The next value is 10, so we will put a tally mark against 10. The next value is 1, so we will put a tally mark against 1. The next value is 3, so we will put a tally mark against 3. The next value is 0, so we will put a tally mark against 0. The next value is 6, so we will put a tally mark against 6. The next value is 8, so we will put a tally mark against 8. The next value is 5, so we will put a tally mark against 5. The next value is 5, so we will put a tally mark against 5. The next value is 9, so we will put a tally mark against 9. The next value is 1, so we will put a tally mark against 1. The next value is 0, so we will put a tally mark against 0. The next value is 7, so we will put a tally mark against 7. The next value is 3, so we will put a tally mark against 3. The next value is 10, so we will put a tally mark against 10. The next value is 5, so we will put a tally mark against 5. The next value is 2, so we will put a tally mark against 2. The next value is 0, so we will put a tally mark against 0. The next value is 9, so we will put a tally mark against 9. The next value is 5, so we will put a tally mark against 5. The next value is 6, so we will put a tally mark against 6. The next value is again 6, so we will put a tally mark against 6. The next value is 10, so we will put a tally mark against 10. The next value is 2, so we will put a tally mark against 2. The next value is 4, so we will put a tally mark against 4. The next value is again 4, so we will put another tally mark. The next value is again 4, we will put another tally mark against 4. And the last value is 1, so we will put a tally mark against 1. So we have marked all the observations. Now it's time to sum them and write the total marks in the frequency column. For 0 patient admitted, there are 3 tally marks, so we will write 3 in the frequency column. For 1, there are 3 tally marks, so we will write 3 in the frequency column. For 2, there are 2 marks, so we will write 2 in the frequency column. For 3, there are 2 telemarks, so we will write 2 in the frequency column. The next is 4. There are 3 telemarks, so we will write 3 in the frequency column. The next is 5. There are total 5 telemarks, so we will write 5 in the frequency column. For 6, there are total 3 telemarks, so we will write 3 in the frequency column. For 7, there are 2 telemarks, so we will write 2 in the frequency column. For 8, there is only 1 mark, so we will write 1 in the frequency column. For 9, there are 3 marks, so we will write 3 in the frequency column. And for the 10, there are 3 telemarks, so we will write 3 in the frequency column. Now we will total this and will check whether all the observations are covered or not. So the total is 30. So we have covered all the observations and created the frequency distribution table for the given data. I hope you understood this sum. Today's assignment is this sum, just like the one we solved. The following data shows the number of defects in 100 box of nuts and bolts. From this data, prepare a discrete frequency distribution. I hope you will be able to solve this sum very easily. Thank you for watching. If you enjoyed this video and found it helpful, please give it a thumbs up. Share it with your friends and subscribe to our channel for more educational content. Don't forget to hit the bell icon to get notified about our latest videos. Click here to check out our other videos on statistics. See you in the next video.